Welcome to a lesson with Dr. Pal. Let's take a look at how we can find the antiderivative of this, the indefinite integral, with using a u substitution. This might look a little funny. Might take a little bit of time to really figure out what to use. You might be scratching our head. But if we kind of think about our derivative rules backwards and things plugged into other things, think about 1 plus 1, this one right here. Notice that this looks like we've plugged something in for x squared, namely square root of x. And you see that over here, square root of x. Also think for a minute, this right here is a lot like the derivative of square root of x because it's x to the negative 1/2. Maybe that's a good choice. Maybe u should be square root of x. This example's semi-complicated because we don't actually see square root of x in what we're doing necessarily, at least as is, except maybe over here, but that's what we're going to be canceling out. Sometimes u substitutions can be tricky and challenging. Sometimes they take just practice and practice knowing what derivatives are and how they work so that we can kind of think about the chain rule backwards a little bit. So in this particular case, let's let u be equal to square root of x. And so we say du divided by the derivative of u, which is 1 over 2 times square root of x, because it's 1/2 times x to the negative 1/2. And notice that in the denominator, that will cancel with that. We'll be left with 1/2 in the denominator, which is the same as having 2 up top. So this will really look like 2 times the integral. I'll factor the 2 out. 1 over, and it looks like now we have 1 plus, see, x is u squared, so plus u squared du. Then we can take an antiderivative of this, which we know is inverse tangent of u. So this is 2 times the inverse tangent of u plus c. And so then we can replace u with what it is, the square root of x. So we have successfully taken the indefinite integral of where we started and using u substitution and ended up getting this. Thanks for watching.